Hello, today we are going to discuss about IEEE 802.11 standard. So this is a standard which is designed by IEEE, that is Institute of Electrical and Electronics Engineer, to define the wireless communication. So in this we will learn about what is the wireless technologies, then the wireless standard, about the wireless standard, that is IEEE 802.11, its working modes, its radio frequencies and the split spectrum techniques, channel use and CSMA-CA techniques through which it transmits the data over the radio frequencies. So we will start with what is a wireless technology. So wireless technology is the technology by using which we transmit the data and voice over the air interface. So in this we will use the radio frequencies to transmit and receive the data and voice. So basically this was the wireless technology was designed to transmit the data, but later on it is also used for transmitting the voice. So wireless communication was developed in 19th century. That is IEEE 802.11 was the first networking standard which was made by IEEE in 1997 to regulate the wireless communication between the devices. So the example of wireless technologies are cell phones, satellite communication, Wi-Fi, Bluetooth, Zigbee, etc. So these are the wireless technologies. So let's start with the wireless standard, that is IEEE 802.11. As discussed earlier, it was designed by IEEE in 1997. The main purpose of designing this standard is to define the wireless communication, like how wireless devices communicate, by using which frequencies it communicate with each other, and how to make the communication secure, to how to add the security to the wireless communication. So it also defines frequencies used by the radio signals, their transmission methods and collision avoidance technique, which we discussed in next slides. So IEEE 802.11 is not used now because its latest versions are used, like IEEE 802.11G and IEEE 802.11AC. So the first is the wireless network using the working mode used by the wireless network. So they use the ad hoc mode and the infrastructure mode. So let's first discuss about the ad hoc mode. So the ad hoc mode defines the direct connection or to end-to-end connection between the two or more wireless devices. So it is also known as peer-to-peer mode, and it forms the mesh topology to connect the devices in wireless network. So the network which is formed using the ad hoc mode is known as IBSS, that is Independent Basic Service Set. So IBSS is a basic unit of organizing a wireless network. So ad hoc mode is used to connect devices in small network where main purpose is to transfer file and share printer. As shown in the diagram, this is a ad hoc mode wireless network where each device is connected to each other using a end-to-end connectivity. The next is infrastructure mode. So infrastructure mode use one or more WAP, that is wireless access point, which is same like a router or a hub. So they use the WAP to connect the wireless devices centrally. So every devices are connected to the WAP and they are connected to each other indirectly. So the configuration of this mode is similar to the star topology of the wired network. So here the two terms are used, basic service set and extended service set. So the basic service set, that is BSS, it is BSS is an area having a single WAP, that containing a single WAP, and every device is connected to that wireless access point. And extended service set is a form of extension form of BSS, that is it contains the more WAP, that is wireless access points. So it provides a stable environment for permanent wireless network installation. So it uses the two identifier like SSID and ESIID, through which they are the areas which are defined by the WAP. So service set identifier, that is SSID, is a standard name given to a single BSS. So it is a 32-bit identification string inserted in header of each frame processed by the WAP. So SSID defines the area having a single WAP, whereas ESSID, extended service set identifier, standard name given to the ESS network, is defined the area having a number of WAPs. So client in ESS network will connect to a WAP having a strongest signal. This diagram shows the infrastructure mode wireless network where devices are connected to a single or a central web, that is wireless access point, or it may be like a router or a hub which connect the devices together. The next is the spectrum technique, through which they transmit the data to each other. So there are three different spectrum techniques used by the wireless devices, like direct sequence spread spectrum, that is DSSS. Then is frequency hopping spread spectrum, that is FHSS. Orthogonal frequency division multiplexing, OFDM. So let's discuss about this. First of all, the discussion about the spread spectrum. So spread spectrum is the where the original signals are spread over a larger bandwidth. This is done to avoid the signal interference. So it is also known as direct sequence code division multiple access. Here which the spreading code or the PN code, that is pseudo random codes, are defined to the user, every user. So each user have their different spreading codes. So spreading codes consist of specific sequence of bits known as chips. So the PN codes are multiplexed with the original message and resultant messages sent to the receiver. So transmitter, here the transmitter and receiver have the same PN code to demultiplex or multiplex the signal. So in this, the spreading codes are used to modulate the original signals to and transmit over the radio frequencies. So as shown in the diagram, there is a data input A, that is the original message that is transmitted by the user in the form of 01 bit, and the user have the PN code that is having the bit rate more than the original message. So here the signal modulates using the XOR gate, that is A XOR B, and it forms the transmitted signal, that is C. So this signal, C signals, is transmitted over the receiver, and when receiver receives this signal, it uses the same PN code that is used by the transmitter, and it demodulates the signal and get the original signal that is sent by the user. So in this way, it multiplex and demultiplex the signal using the PN codes. The next is frequency hopping spectrum. So here the as in DSS, we are using the different codes to modulate the signal. Here we're using the multiple frequencies to modulate the signal. So multiple frequencies is used for sending packets in the network. Every user uses different frequency at different times. So frequency of carrier is periodically modified following a specified sequence of frequencies. So if we use the different frequencies to send the signal, so the hackers or the are not used to identify the signal, how we are transmitting the signal or which frequency. So this sequence is known as hopping sequence, as our packets are hopping over the different frequencies. So as shown in the diagram, there are different frequencies and the packet is transmitted over it. So the first packet is transmitted over the higher frequency, then the second packet is transmitted, then the third, then fourth, fifth and sixth. They are transmitted over a different frequencies and at the different times. So in this way, the frequencies hopping spread spectrum is used. The next is orthogonal frequency division multiplexing. So in this, the OFDM, a large number of closely spaced orthogonal subcarriers are used to carry data of server users. As in various division multiplexing, we use the only single carrier to modulate the signal, but here we are using the many subcarriers, orthogonal subcarriers, to modulate the signal and send over the same frequency. So this spacing provides the orthogonality, and each subcarrier is modulated using a different modulation technique like QAM and PSK, quadrature amplitude modulation or phase shift keying, and this significantly improves the spectral efficiency. So as shown in the diagram, there are different user data that is transmitted by using the different frequencies, and they are transmitted by using the different subcarriers that are orthogonal to each other. The next is the channel used by the wireless networks. The channels which are assigned by the IEEE 802.11 to every wireless devices. So there are two channels, 2.4 gigahertz and 5.0 gigahertz. So here 2.4 gigahertz, it defines the 14 channels and of 20 megahertz. So most of the web here use these frequencies, and it is a overcrowded channel. So here we can't use the neighboring channels to the allowed to the different web, but here we use 1, 6 and 11 channel by default because they are non-overlapping channel. If we use the same neighboring channels and allowed to the web, then they cause the interference of the signal. So a 50 gigahertz band defines 40 different channel, and it uses the concept of automatic channel switching to reduce overlapping. The next is the technique that is used by the wireless devices to communicate with each other, that is CSMA-CA. That is wireless network use CSMA-CA technique, that is carrier sense multiple access collision avoidance. As earlier we have discussed about CSMA-CD technique that is used by Ethernet or a wire network to send the data over it. Here we are using the carrier sense multiple access collision avoidance. The wireless devices cannot detect the collision in the network because the wireless communication use half duplex transmission method, that is the sender and the receiver doesn't talk simultaneously to each other, or wireless devices cannot listen and send at the same time, so they can't detect the collisions. Whereas if two wireless devices packet collide, then there is no symbol to detect electrical peak. As in wired media, we use the electrical peak to detect the collision in the network. As here we are transmitting the signals wirelessly, so we can't detect the collision by using the electrical peak method. So we can't detect the collisions in the wireless networking. So here we use the technique CSMA-CA, that is collision avoidance. So wireless devices avoid the collision to occur in the network. So they use the two method like distributed coordination function DCF and point coordination function, that is PCF. So most of the time the DCF is used, distributed coordination function, which specify the rules for sending data onto the network media. So it checks the radius link that is clear before transmitting and to avoid the collision. So it checks the link before sending the packets over it. So this is all about IEEE 802.11 standard. Thank you.